Okay, this is chapter 9 over right triangles out of the study guide. Starting on the first one, 9a. In triangle ABC, angle A is a right angle. And so I'm going to draw that in the picture. Measure of angle B is 60 degrees. And AB is 14. So this includes one side and two angles. So we can go to our triangle sum theorem. We can figure out that the other angle has to be 30 degrees here because of the fact that they all three had to be a 180. And normally if we had two sides, let's call this x and y. If we had two sides, we could normally find the third by using Pythagorean theorem, but we don't have two sides. So we've got to somehow use the angles and the sides together to come up with the missing sides. That means we're going to have to go back to an old friend, that Indian woman, Sohcahtoa, right? Sohcahtoa. She sounds like she went with Lewis and Clark or something. So some old hippie caught another hippie. I'm not even going to finish that one, but sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent is a opposite over adjacent. So we're going to use trig. Finding BC. BC is our y value here. And if I'm using the 60 degrees that they gave us, then y is going to be the hypotenuse. X is going to be the opposite. And 14 is going to be the adjacent sides. So using trig, then I'm going to want to include adjacent and hypotenuse, which means I'm going to go to cosine. So cosine of our theta equals adjacent over hypotenuse. In this case, our theta is 60 degrees, so the cosine of 60 degrees is equal to adjacent, which is 14, divided by hypotenuse, which is y. And I'm going to get myself a box here to work in. Let's see if I can. Well, Mr. Conaway can figure out how to run his smartboard and work out real well here. Let's try that again. Okay. There we go. Yeah. All right. So as I said, it was 14 over y here. And so if I multiply both sides by y, I get y cosine of 60 degrees equals 14. And then to solve that, I am going to be dividing both sides by cosine of 60. Degrees. So y equals 14 over cosine 60. I'm going to have to ask one of my class students to figure out what that number is for me in your calculator. So please divide 14 by cosine of 60 degrees. Make sure that you have the calculator in decimals, not in radians. $28, that's right. It's going to be exactly equal to 28. So we don't even need the approximately. This is a 30, 60, 90 right triangle, which means that the hypotenuse will be double the short side. Okay, in 9b, they want us to find AC, which is x. So if I'm looking for x, then I'm going to use opposite and adjacent, which is going to be tangent. So tangent theta equals opposite over adjacent here. Now, if you have the 30, 60, 90 rules memorized, you can use those, and that'll make it a lot quicker. But if you don't, trig works for everything. So tangent of 60 degrees equals x over 14. Multiply both sides by 14. And I'm going to get x equals 14 tan 60. And can you guys put that in your calculator for me? 14 times tangent of 60. And tell me what we're going to get. Yeah, you might have a mistake there. Say again. 24.2. Okay. Anybody going to back them up? Does that sound about right? Good. Okay. Well, it's actually 14 square roots of 3. Okay. Try multiplying 14 times root 3 and see if you get 24.2. Okay. And another way we could have done that is we also, since we'd already found this was 28 and we knew 14, we could use Pythagorean Theorem and get the same thing, 14 root 3, or 24.2. Okay. And let's move my box here. So the longer leg of a 30, 60, 90 triangle is 12 feet long. Find the shorter leg. All right, so we've got a 30, 60, 90 triangle. How do we know which one is long, which one is short? Well, you guys remember the Hinge Theorem tells us about the size of the angle, determining the size of the sides. So which angle is the biggest? 90. So which side should be the biggest? The one across from 90, which we call the hypotenuse. Hypotenuse is the largest, okay? So which one will be the shortest then? The one across from 30 is the shortest, and that makes 60, the one across from 60, the medium. Out of the legs, being that this is a right triangle, it has 2 legs and a hypotenuse. Which is the longer leg? Short or medium? Yeah, medium is going to be the longer. Okay. So if the longer leg, which is the medium one here, is 12 feet long, so I'm going to say this is 12 feet from tip to tail, find the shorter leg. So what can I use? I have angles and I have sides. So when I mix those together, what do we use? Trig Sohcahtoa. Yes, you can still use your 30, 60, 90 rules. It's a little harder in this case because you're starting with 12, where you should have a square root of 3. I would rather just use trig. Makes it easier for me. I got an S, which is opposite of my 30. I've got a 12, which is adjacent to my 30. So I'm going to use TOA for opposite and adjacent. So I'm going to say tangent of 30 degrees equals opposite, which is S, over adjacent, which is 12 feet. Multiply both sides by 12 feet, and I'm going to get S is equal to 12 tan 30 degrees. Somebody put that in your calculator. Tell me what you get. 4 roots of 3. And what is that going to be approximately? Around 5 point something maybe? 6.9? Okay, 6.9 feet. Don't forget feet along there. Okay. Looks good to me. I'm going to erase this. Okay, the hypotenuse of a 45, 45, 90 triangle is 12. Find the lengths of the legs. So this is a 45, 45, 90. which means that these two are the same, which means that these two are the same, and the hypotenuse is 12. Now, there's a couple ways you could do this. You could use trig, you could use the 45, 45, 90 rules, or you could just use Pythagorean theorem. If these two are the same, can I just use a letter to represent them? What do you want to use here? What letter? Sure, A. Yeah, let's not get stuck on X. So if I wanted to do Pythagorean theorem, what would I do here? A squared plus A squared equals. Okay, if I take an A squared and add it with another A squared, how many A squareds I got? Yeah, you got 2 A squareds equal to 144. Divide both sides by 2. A squared equals 72. Square root both sides, and I'm going to get A equals the root of 72, which when I reduce that, I know 72 is the same as 36 times 2. So that's going to become 6 roots 2. 6 root 2. Good. We're done with that one. Okay, find the length of the diagonal of the rectangle ABCD. There's our diagonal. What do we know about rectangles? Okay, opposite sides are equal. What else do we know about them? Equiangular, the one-word definition of a rectangle. I love it. Equiangular, which means all 4 angles are equal. And what's the only measurement that could be for all 4 of those angles? 90 degrees, which what does that create for us? A right triangle. This is a right triangle here. And if that's a right triangle, can I find x? What am I going to use? Pythagorean theorem, 2 squared plus 8 squared equals x squared. 4 plus 64 equals x squared. X equals the square root of 68. And that's going to be what? 2 times 34. So 4 times, don't give me a line, 17? So that would be 2 root 17, I believe. Am I right on there? Somebody put that in their calculator. See if that's right. Square root of 64. 68 is 2 root 17. Okay, there we go. Moving on through. Okay, find sine of x in the given right triangle. So in this case, we're trying to find the angle x here. Well, we're not trying to find the angle, I'm sorry. We're trying to find sine of x. That'll be 10. We're trying to find sine of x, not the angle x. So the sine of x means I'm going to use sine x in this case, or theta, equals opposite over hypotenuse. Opposite in this case is going to be 20. Hypotenuse is always across from the 90. So I'm going to have sine x equals 20 over 40. 20 over 40 is going to reduce to 2 over 4, which also reduces to 1/2. So sine x equals 1/2. Now, question for you. Do I need to take the sine inverse of both sides? Did the question ask me for the angle? What was the statement? What did the question want? It said find sine x. Have we found sine x? Yes, we have found sine x. Now, we could continue and find the angle, but we have found sine x, so we're good. All right, next, use the diagram to find m angle x to the nearest degree. Measure of angle x, so measure of angle x. So I can pick any which way I want to do here. I kind of like sine, so I'm going to stick with that. Sine of x equals 15/40. That's going to be opposite over hypotenuse. And whenever I reduce this, I'm going to end up getting 3/8. And so sine of x equals 3/8. But they actually asked me to find the measure of angle x now. They didn't want us just to find sine x. They want us to find the measure of angle x. So what should I do to find the measure of angle x here? That's right. If I want to undo sine of x, then I need to utilize the inverse sine of x. Okay, and then I'll do the same thing over here. And I'm going to get that sine inverse of sine undo each other. And they give me an x equals sine inverse of 3/8. Plug that into your calculator. I can't do that in my head. What was it? 22.1 degrees. Approximately 22.1 degrees. Don't forget about that shift sign button for sine inverse. Okay. A ladder 8 meters long just reaches the top of a building and its foot makes a 70-degree angle with the ground. So we've got a building. We've got a ladder. And they said it just reaches the top of the building and it has a 70-degree angle with the ground. Of course, our buildings are generally built at a right angle. There are a couple in the world that are not, but most of your buildings are going to be built at a right angle. The ladder is 8 meters long. Now they want us to find the height of the building H. This is a right triangle, so we can use trig with it. From 70, H is opposite. 8 meters is hypotenuse. So which one uses opposite and hypotenuse? Sine theta equals opposite over hypotenuse. That'd be so, or some old hippie. So we're going to plug in sine 70 degrees equals, opposite is H, hypotenuse is 8 meters. To get rid of the 8 meters, we're going to undo the division here by using multiplication. 8 meters divided by 8 meters is 1. And 8 meters times sine 70 is on the other side. So H is equal to 8 sine 70 meters. H is approximately what? 7.5 meters. Okay, find the value of x for each picture below. Let me extend the page here so I can have a little more room. This is a 45, 45, 90. So if we just remember our rules, If you have two angles that are the same in a triangle, like 45 and 45, what kind of triangle is that? If it's got two angles the same, it is isosceles. And if it's isosceles, what else do you know about it? Two equal sides. And the hypotenuse is not going to be the same as any other side. So those two have to be the same. So what is x? Good. All right, in 9J, we have a 25-degree angle. Is 34 opposite, adjacent, or hypotenuse? If this is going to be adjacent, remember, if you're ever confused about it, always look for opposite and hypotenuse first because they're easy. Hypotenuse is always across from the 90. So that leaves 34 to be adjacent. So if I'm going to use adjacent and hypotenuse, then I need to use cosine. So I'm going to say cosine of 25 degrees equals adjacent, which is 34, over hypotenuse, which is x. Now, I can remember my proportionality properties allows me to just swap those. And I can get that x equals 34 over cosine 25. And that's not magic, that's just math. Multiply by x, divide by cosine 25, and you're there. And what is x going to be approximately? 37.5? Okay, and they did not give us units there, so we're good. And the final two questions for this section. They wanted us to find x in this one. This is going to be opposite and hypotenuse, which means we're going to use sine. So sine of 15 degrees equals x over 12. Multiply by 12 on both sides. 12 over 12 is 1. X equals 12 sine 15, which, what was that approximately? 3 root 6, which is, that was equals exactly, and then that is approximately, when you round it to the first decimal, what? 3.1. Okay. And 9L. So we've got a 30 degree here. Now this goes back to our 30, 60, 90. If we remember those, that's going to make this easy because this is a 60 degree. And that means that if this is x, then this has to be twice x. And this has to be x roots of 3 down here. What is x? If this is x, this is double x, and this is x roots of 3, what does x have to be? Yeah, look at it right here. The x is that 3. So x equals 3. Now you could use trig to have found that out as well. You would use the tangent of 30 equals x over 3 root 3. And that is the end of chapter 9.